So the next topic we have is principle of negative feedback amplifier. In the previous class we had seen what are the types of feedback networks. So connections, okay. One is positive, the other one is negative. So we had also seen what are the advantages of negative feedback. So now we'll see on what principle. So the negative feedback amplifiers it works, okay. So that is what it is, principle of negative feedback amplifier. For this, I'll consider a block diagram of a negative feedback amplifier, okay, which is having an amplifier with a gain A, okay, and a feedback network with a gain which is equal to beta. So for this, I'm giving an input to the mixer. It is Vs. It is a source input, okay, and the signal from the feedback I am considering it as Vf, that is feedback signal. So it is negative feedback, so the symbol is negative, you should write here. So sign, okay, here it is Vi. So the part of the output is given to your feedback network as an input, right? Is it a V naught here? So here you will get a Vf. So this is V naught. This is how we have to write the block diagram of negative feedback amplifier. So this represents it is negative feedback. So here we have what are all the things we have is Vs, it is equal to source input. Yes, so Vs represents it as source input, and I have Vi which is input to the amplifier. Vi represents it as input to the amplifier, and then we have beta. So beta represents gain of the feedback network, gain of the feedback network. So gain is nothing but here output by input. Gain, it is always represented by output by the input. So that is what is output you are getting for the given input, that represents a gain, okay. Next we have V naught, so which represents output of the amplifier. Output of the amplifier. And we have A, which represents gain of the amplifier. Gain of the amplifier. Vf represents it is feedback signal. Yes, so now, so this is the diagram, and we have these many parameters here, Vs, Vi, beta, V naught, A and Vf. So let us consider the gain of the basic amplifier or open loop gain of the amplifier. This one, so this is amplifier A, right? I am considering the gain of this amplifier when there is no feedback. I am just considering this part, okay? That is Vi, A and V naught, okay? I am not assuming this feedback. So that is what. So let me take the gain of the basic amplifier, that is A. You have here Vi and output is V naught. So now I can write the gain as gain is equal to, it is gain of the amplifier, or you can say it is open loop gain. Open loop. When the no feedback is connected, it is called as open loop gain of the amplifier, which is given by A is equal to V naught divided by Vi. That is output divided by input. Let me take this as equation 1. Now I'll assume overall gain of the amplifier. Gain of the amplifier. So this is gain of the amplifier. This is overall gain of the amplifier with a feedback. Okay, this is with the feedback, or you can also say this is R. It is a closed loop gain. Without feedback, it is called as open loop gain. With the feedback, it is called as closed loop gain. So which is represented by AF. Okay, so that is given by, so with the feedback what we'll write, that is a V naught divided by Vs. isn't it? Overall gain, this it is your amplifier. If you consider with feedback, so output is V naught and input is Vs. So this is given by V naught divided by Vs. Let me this equation 2. Okay, so now from equation 1 we can write V naught is equal to A into Vi, is it not? So this, let me take it as equation 3, and we also have Vi. So it is input is equal to Vs minus Vf, since it is negative feedback. So we can write Vs minus Vf. So this is equation 4. Okay. Now for the feedback network, that is your beta feedback network, we can write beta is equal to, for the feedback network, what is the input here? It is V naught, output is Vf. So the gain can be written as Vf output divided by input V naught. Okay, so take this as equation 5. So now, so from this I can write Vf is equal to beta into V naught. So let me take this as equation 6. Okay, now substituting this equation 4. So I have Vi is equal to Vs minus Vf, right? So what is the overall gain of the amplifier? We can write it as V naught is equal to A into Vs minus Vf. That is V naught is equal to A into Vi. We have, right? Now you substitute this Vi is equal to Vs minus V naught. Sorry, Vs minus Vf. Now again you substitute for Vs. So Vf, what you can write for Vf? It is beta into V naught. Okay, so that substitution part. So now we'll substitute equation 4. Equation 4 in equation 3. So that is equation 4, I have Vi is equal to Vs minus Vf. Okay, and 3 we have V naught is equal to A into Vi. Okay, substituting this Vi in the V naught. So we'll be getting V naught is equal to A into Vs minus Vf. Correct? So now I can write this V naught is equal to A into Vs minus A into Vf. Correct? So now from equation 6, we have what is equation 6? Vf is equal to beta into V naught you have. So substitute this in this equation. Okay, that is, let me take this as equation 7. Substitute equation 6 in the equation 7. So I'll get V naught is equal to A into Vs minus A into Vf is equal to beta into V naught. Is it not? Now let me take all the V naught together on the LHS side. So I'll get V naught plus A into beta into V naught. So this will be equal to A into Vs I'll get. Correct? So taking the common here, V naught, I'll get 1 plus A beta. Correct? And here I'll get A into Vs. So let me take this now. V naught divided by Vs, which will be equal to A divided by 1 plus A beta. So this is what is this V naught by Vs represents? So this is the overall gain of the amplifier with the feedback, that is AF is equal to, is it not? AF is equal to A V naught divided by Vs, which will be equal to A divided by 1 plus A beta. So your AF represents it is overall gain with the feedback. So which will be given by AF is equal to A divided by 1 plus A beta. So now here we can observe, so which is equal to V naught divided by Vs. Okay, so here you can observe the denominator, it is a higher value, correct? So the negative feedback reduces the gain by factor 1 plus A beta. So gain which is divided by 1 plus A beta, right? So we can write, therefore negative feedback reduces the gain of the amplifier, gain by a factor, how much the factor? It is 1 plus A beta. This is what how you need to show the negative feedback reduces the gain by factor 1 plus A beta. We'll just summarize this. So here you can get two type of questions on this. One is you may get explain the principle of negative feedback amplifier, okay, or you may get the question like show that so the negative feedback reduces the gain of the amplifier, okay, by 1 plus A beta, or they can ask you how the negative feedback reduces the gain of the amplifier, justify. If they ask the question like this, what you have to write? The same for all the three questions, the answer is same. You need to explain the principle of negative feedback amplifier. Here I have taken the block diagram, okay, general block diagram of a feedback amplifier with the feedback beta. So with the feedback network gain beta, okay. So amplifier input we are giving Vi here, we output as V naught, beta it represents a gain of the feedback network. So Vf represents it is feedback signal, okay. So what are all the parameters we are considering here is Vs, which represents source input, Vi input to the amplifier, beta is a gain of the feedback network. So we can write this as beta is equal to Vf divided by V naught. It is output by input. So next you have V naught signal. So it is output of the amplifier. Next we have A, which represents gain of the amplifier. Vf, which represents the feedback signal. Okay. Now the very first thing what you have to consider is open loop gain of the amplifier. That is gain of the amplifier without the feedback. Without feedback, what is the gain of the amplifier? So that we can say that as open loop gain, which will be equal to A will be equal to V naught divided by Vi. I am not considering the feedback here, so it is V naught divided by Vi. Let me take this as equation 1. Now you write overall gain of the amplifier with the feedback, or you can also call it as closed loop gain. So which will be AF is equal to V naught divided by Vs. It is overall gain we are considering with feedback also. So output is V naught. So input to this is Vs. So divided by Vs. So it is equation 2. From equation 1 we can write V naught is equal to A into Vi. Let me take this as equation 3. Write Vi is equal to Vi. We can write this Vi to the amplifier. Input to the amplifier is given by difference between the source input and the feedback signal. So that is what Vs minus Vf. Okay. Now for the feedback network, I can write the gain as beta is equal to Vf, that is output divided by input V input V naught. Okay. Now from this we can write Vf is equal to beta into V naught. Now I'll make the substitutions to get the overall gain of the amplifier. So you can observe I'm substituting equation 4 in the equation 3. Equation 4 is Vi is equal to Vs minus Vf. So substituting for this equation in the equation V naught is equal to A into Vi. So after substitution I'll get A into Vs minus Vf. So V naught will be equal to A into Vs minus A into Vf. So now from equation 6. So from equation 6 we can write Vf is equal to beta into V naught, isn't it? So this is what your equation 6 is. So now substitute this Vf is equal to in the equation 7. So I'll get V naught is equal to A into Vs minus A into beta V naught. Then simplifying this, okay, we'll get overall gain as Af is equal to V naught divided by Vs which will be equal to A divided by 1 plus A beta.